Oops. Hey guys, how's it going today? Today we're going to review just a couple things that I thought might have confused some people about mixtures versus compounds. Some things I've heard kids say in the past is something like, honey is a mixture and a compound. That's an incorrect statement, as well as the other two. The other two are also incorrect statements. I want you guys to take a moment and think, why are these statements incorrect statements? Okay, pause the video if you need more time. Honey is a mixture and a compound. That is an incorrect statement because compounds are pure substances. So a mixture is kind of one set of things that are impure, so things that have got two or more chemicals in them. And then a pure substance is something that's only made up of one chemical. So like it's all sugar or it's all water. But a mixture would be something like sugar and water combined. Honey is a mixture of like sugar and water and some other stuff. So honey would be a mixture, but then it couldn't be considered a compound. If you want to talk about a compound or a mixture that's smooth, you talk about something that's homogeneous. So homogeneous is the word to describe a smooth mixture that's kind of all the same thing. So the phrase sugar is a pure substance and homogeneous, that's incorrect because sugar is a pure substance, so it can't also be homogeneous. So in this case, the word you're looking for is not homogeneous, it's compound. So homogeneous only describes mixtures, it does not describe things that are pure. In order for something to be homogeneous, it's got to be made up of two or more different chemicals. So in this case, I wrote down the chemical formula for sugar with the letter and the numbers, so you knew it was a chemical, you knew it was pure. And then lastly, chocolate chip cookie dough is a homogeneous mixture. This is wrong because chocolate chip cookie dough is chunky. So if things are smooth, we call them homogeneous mixtures. If they're chunky, we call them heterogeneous mixtures. So that phrase homogeneous and heterogeneous tends to mix people up. I tend to think of homogeneous as smooth, heterogeneous as chunky. That's how I remember it, kind of like peanut butter in that case. A smooth peanut butter would be a homogeneous solution. Chunky peanut butter would be a heterogeneous solution. So hopefully that helps. Mixtures versus pure substances. Here are a bunch of examples of mixtures. Here are a bunch of examples of pure substances. What you'll notice about all the pure substances is that they all have a chemical formula next to them. And then particularly I wanted to actually, yeah, they all have a chemical formula next to them, which is all one or more capital letters, and then sometimes some numbers as well, and sometimes some lowercase numbers as well. So any pure substance will have a chemical formula next to it. Mixtures do not have chemical formulas because they're made up of more than one chemical. So hopefully that difference makes sense in your mind. So all pure substances, what do they have in common? A formula. Okay, here are the five or the six different mixtures. Why don't you go ahead and think, okay, is pop heterogeneous or homogeneous? And do that for all of them. Try and place each one in a category, either heterogeneous or homogeneous. If you need more time, let me know. Here we go. Okay, pop is heterogeneous because pop is made up of like a liquid and a gas. So that gas being in there makes it kind of chunky. Sunscreen is smooth. So sunscreen we would say is homogeneous. A lava lamp we'd say is heterogeneous because it's got those bubbles in there. Jello we would say is homogeneous. It's nice and smooth. Cereal and milk we'd say is heterogeneous just because milk and cereal are two different states, solid and a liquid. And soft serve ice cream we'd say is homogeneous. So remember, heterogeneous means chunky, homogeneous means smooth. So hopefully you can see here how pop is heterogeneous, a lava lamp is heterogeneous, and cereal is heterogeneous. In all these cases, they all look like kind of chunky things, except for maybe pop, but that's a bubbly thing, so it's also heterogeneous. Versus sunscreen, jello, and soft serve ice cream, they all have a uniform consistency. They all kind of look the same. There don't seem to be chunks anywhere in anything that's homogeneous. Hopefully that makes sense. Chunky versus smooth. Hopefully that helps. Okay, element versus compound. I'm just going to go ahead and organize them for y'all. And what I want you to notice here is that the elements all only have one capital letter, and our compounds have more than one capital letter. So compounds are made up of more than one element. An element is made up of just one element, one capital letter. Hopefully this makes sense here, element versus a compound. And here are some pictures of each element. Here are some pictures of each compound. Notice that all of these here are chemicals. And same thing over here, they're all kind of chemically. Hopefully that makes sense. It's kind of hard to picture hydrogen and oxygen because they're both gases, so they're pretty much invisible, you know. But carbon looks like a pure black, like kind of like coal, is pretty much carbon. Great. Okay, so let's talk physical and chemical changes. This is kind of the meat and potatoes of today. Go ahead and see what you know. I bet you've heard of physical change versus chemical change before. Go ahead and see for each one of these. Think, is it a P? Is it a physical change? Or is it a C? Is it a chemical change? Go ahead and try these out. P or C. Dissolving sugar in water, that is a physical change. Boiling aluminum, physical change. Burning a bagel is a chemical change. A steel nail rusting is chemical change. Ice melting is physical. Mowing grass is physical. Grass clippings rotting in the backyard, however, is chemical. Chopping broccoli is physical. And a phase change is physical. You might have wondered, what is a phase change? We'll talk about that in a little bit. Okay, so how can you tell? Here's the main difference. Physical changes, the matter doesn't change. The chemical formula you start with is the same as the chemical formula you end with. So if we look back at all of these, sugar, aluminum, you boil aluminum, it's still aluminum. You're not changing the aluminum. It just goes from liquid to gas. Dissolving sugar, the sugar in the water still tastes like sugar water. You still taste the sugar. The water and the sugar are still the same thing. They don't change chemical formulas. If ice melts, it's still water, so same formula. Mowing grass, the grass is now gone from being tall to being short, so the grass is still the same, just a different height. Chopping broccoli, same thing. Broccoli goes from being tall to short. And then a phase change, like melting ice or boiling water, it's all water. It's just different phases. It's either a solid, a liquid, or a gas. So when we're talking about a phase change, we're talking about changing from a solid, a liquid, or a gas to a gas, a liquid, or a solid. That's kind of what we're talking about there. Okay, so physical change, matter doesn't change. Please write that down. Chemical change, matter changes. You're going to get new chemical formulas. So you burn a bagel in a toaster, you got a new chemical formula. A steel nail rusts, new chemical formula. You got iron oxide in there instead of just regular iron. Glass clippings rotting, now you've got bacteria and stuff. So it's new chemical formulas. So hopefully this makes sense here. The difference how all of these up at the top have no new chemical formulas, and all these at the bottom, new chemicals are being formed. There are 4 signs to a chemical change. Please write these down. Bubbles, change in energy. That means hotter or colder. That means flames. That means light. That means sound. Any of those things could be energy. Change in color. Be careful with change in color. A chemical change with a change in color would be you mix blue and red together and you get orange. If you mix blue and red together and you get purple, that's not a chemical change. So it has to be 2 things mixed together and then an unexpected color happens. Bubbles for gas production, this doesn't mean boiling. Keep that in mind. If you have something boiling, that's you're adding heat and it's changing. Bubbles would be you mix 2 things at room temperatures and all of a sudden now it starts bubbling. And then the formation of a precipitate is kind of the opposite of bubbling. Where you mix 2 liquids together and then you get bubbles, that's the formation of gases. If you mix 2 things together and you get a precipitate, that's the formation of a solid. So formation of a precipitate means you form a solid out of 2 liquids. So here's one showing bubbles forming. Here's one showing a precipitate, 2 liquids mixed together, and then you see that yellow solid forming at the bottom. There's an energy change. There you can see some explosions. And then lastly, we've got a color change. Here we mix 2 chemicals together and it turned clear to purple. This is called the titration. You'll do these in chemistry eventually. Why is a phase change a physical change? There's no change in chemicals. You're starting in with cell stuff. Why is dissolving a physical change? I get this question all the time too. Again, no change in chemicals. Salt and water gives you salty water. So hopefully both of these kind of answer those 2 common questions. A phase change and dissolving are both physical changes just because there's no change in the chemicals. What you start with is the same as what you end with. And then lastly, what are the signs of a chemical change? These will come up time and time again. So make sure you're aware of the 4 signs of a chemical change. Make sure you have those down in your notes. I talked about this already. If you mix red and white and it turns pink versus if you mix red and white and it turns yellow. Pink means physical change. Yellow means chemical change, just because it's something you wouldn't expect. You mix red and white, you're expecting pink. You get yellow, that's not what you're expecting. Chances are there's a chemical change happening. Bubbling from boiling versus bubbling from mixing 2 chemicals together. Again, boiling is a physical change. Mixing 2 chemicals together, Not expected that it'll boil. That's a chemical change. Um, so boiling is a physical change because water is turned into steam. Steam is the same thing as water. And then, yeah, just change in color, mixing red and blue and get purple. That's physical. Mixing red and blue together, get orange. That's chemical. Great. Hopefully, you guys know the difference between a physical and a chemical change, and hopefully, you guys feel comfortable trying out the little daily assessment. Thank you so much for listening. Have a great rest of your day.